this problem, let's take a look at number 3. So number 3 is kind of our messiest case situation. We have a 4 over x plus 1 is less than or equal to 2 over x plus 3. So we've got a number of issues here. First of all, one side of this inequality needs to be 0. Well, the easiest way to get one of these sides to be 0 is to take the right-hand side and just move it over to the left. Well, it's a positive 2 over x plus 3, so to move it, we're going to subtract a 2 over x plus 3 from both sides. And what that will do is move it from one side to the other. So now what we have is 4 over x plus 1 minus 2 over x plus 3. The less than or equal to is still the same, but now there's just a 0 on the other side. We're getting close. Now we have a problem that we've got two fractions. They are on the same side at least, but we've got two fractions. We can only deal with one. So how do I get these two fractions, which are subtracted, to turn into one? Well, I need to get a common denominator. Of what? The common denominator will actually have both denominators, an x plus 1 and an x plus 3. Because they're completely different denominators, there's no way to turn one into the other. We have to include both in our common denominator. Well, let's take a look. Well, notice that the first fraction already has the x plus 1. So it's missing the x plus 3. So what that means is I need to multiply the bottom and the top by an x plus 3, which gives me now a 4x plus 3 on top. So a 4 times x plus 3 on top. Okay, next one. Next one, let's see, already has the x plus 3 on it. So that means it's missing the x plus 1. So I need to multiply the bottom by an x plus 1, but then I have to multiply the top by an x plus 1. But then now I have a 2 times x plus 1 on top. I am getting closer and closer. Now, in order to put these two fractions actually together, they had to have a common denominator. We're there. We have a common denominator. We have an LCD. The problem is I need to be able to add and subtract, which means I need to distribute my 4 on the first one. And be careful, a negative 2 needs to get distributed on the second one. Well, multiplying out the 4 on the first one will give you a 4x plus 12. Multiplying out, be careful, a negative 2 on the second group will give us negative 2x minus 2. Now we can go ahead and combine like terms. We've got a 4x and a negative 2x, which will give us a 2x. We've also got, let's see, a 12 and a negative 2, which will give us a positive 10. And we have a common denominator. That's why we were able to add and subtract normally, but the common denominator stays the same of x plus 1 and x plus 3. The only thing you may want to check to see is if anything factors, and you do indeed have one thing that factors. You do have that your numerator, your 2x plus 10, can factor by pulling out a 2, which will leave you out with an x plus 5, but notice that nothing's going to cancel, which is good. We still have our x plus 1 and our x plus 3 on the bottom, and it's still less than or equal to 0. And remember, this was our goal. We want one big fraction, no matter how messy it is, and 0 on the other side. So once you hit your goal where you've got one fraction on one side and 0 on the other, then we can go ahead and find our critical values. And let's talk about our critical values. Well, the first part of our critical values is worried about when the top equals 0. Well, let's see. We've got a 2 times x plus 5 on top, and we're worried about when that's going to equal 0. Well, this is going to equal 0 when it doesn't matter about the 2 because we can divide both sides by 2. And what that will give us is that will cancel out our 2. and leave us with just an x plus 5. And on the other side, 0 divided by anything is still 0. So you'll subtract the 5 from both sides and get x equals negative 5. And remember, this is where you're 0, so this is where you're going to cross the x-axis. The second part of this is to talk about when your denominator equals 0, when your bottom equals 0. And there's going to be two values that make our denominator equal to 0 this time because our bottom has two pieces. So we're worried about either x plus 1 or x plus 3 because it's already factored equaling 0. So we'll be worried about either one. Either the x plus 1 could be 0 or the x plus 3 could be 0, which means we get two values. When we subtract 1, we get negative 1. When we subtract a 3, we get a negative 3. And this means we've actually got two vertical asymptotes, one at negative 1 and one at negative 3. So this is the first time that we see critical values. We actually see not 1, not 2, but 3 critical values. So when we actually go to draw our number line here, we're actually going to put 3 values, starting out with negative 5, then negative 3. Remember, we're working our way from smallest to largest, then negative 1. So 2 of these are vertical asymptotes. That's negative 3 and negative 1, so I'm going to draw them in as such as vertical dotted or dashed lines at negative 3 and negative 1. Remember, negative 5 is where you actually cross the x-axis, so we should have a point there. Now we need to test some values. We need to take one from each region and plug in a value and see what it does to our function. So our first region we've got is anything before negative 5. Our second region is anything between negative 5 to negative 3. Then our third region is anything between negative 3 to negative 1. And our last region, our fourth region, is anything after negative 1. So our first region, anything before negative 5, let's plug in negative 6. And again, go back. Which function are we looking at? The final one that we came up with that has 0 on one side, which looks like 2 times x plus 5 on top, over x plus 1 times x plus 3 on the bottom. So let's see what happens when you plug in a negative 6. Well, let's see. If you plug in a negative 6 on top, you'll end up with a negative on top and a negative on the first parentheses for the bottom and a negative on the second parentheses. Well, notice that the 2 negatives on the bottom will cancel out, leaving you with a positive, but you'll still have a negative left over. And what that means is that your first little portion here is going to still be negative. And that means it will end up being below the x-axis. So we'll start off with our first region below the x-axis. Now let's take a look at region number 2, which is between the negative 5 to negative 3. Well, there's only one good number in there, is negative 4. So let's see what happens again. So plugging in negative 4 on top will actually give us a positive on top, but will give us 2 negatives on each of the parentheses pieces on the bottom. Just like before, though, the 2 negatives on the bottom will cancel each other out, so you'll just have the positive on top, which means our final answer here for something in the region 2 will end up always being positive, which means we'll end up being, if we're positive, we'll end up being above the x-axis. So we'll continue getting close to the asymptote and being above the x-axis. Okay, continuing along, let's see. Region 3. In region 3, we're going to be looking for something between -3 and -1. Well, let's use the easiest one as -2 and see what happens when we plug in a -2. Well, when you plug in a -2, you'll still end up with a positive on top. And in your first set of parentheses, a negative. And the second set of parentheses, you will have a positive, though. So what this means is we will have a positive divided by a negative, which will end up being negative. And because we do end up with a negative, that means we're going to end up with that region completely below the x-axis. Now notice it does not in region 3 cross the x-axis at any point in time because we didn't find out any other values where we cross the x-axis. So that whole thing has to stay below the x-axis. So it should be something like this in order for the whole thing to stay below the x-axis. Okay, last region is region 4. So region 4 is anything after -1. Well, easiest thing after -1 is 0. And let's see what that does for us. Well, plugging in 0 to the top will still get us a positive. And plugging a 0 on the bottom will get you a positive on both pieces. So if we've got all positives on top and bottom, it means there's no way we could get anything but another positive. So that means we'll end up above the x-axis in our fourth region, getting close to the asymptote and doing something else, but always staying above the x-axis. So let's remind ourselves of what we were looking at. We were looking at 2 times x plus 5 over x plus 1 times x plus 3, and we had 0 on the other side. Let's go look and see what inequality was in the middle. It was a less than or equal to. Well, what does less than or equal to 0 mean? It means that you want which parts of your graph are below the x-axis. Well, there's 2 regions that do that. As staying completely below the x-axis, that's region 1 and region 3. So let's write out our final answer in interval notation, reading it from left to right. Well, what it does is region 1 starts on the left-hand side at -infinity and works its way up to -5. And then we jump over to region 3, which starts at -3 and ends at -1. Now remember, -3 and -1 are both vertical asymptotes. So no matter what the problem says, we're going to always use parentheses on those because they're vertical asymptotes. Okay, we also always need to use a parentheses on infinity, so we'll use a parentheses on the -infinity. However, we need to decide what we're going to be doing with -5 here. Well, because our original problem did have the equal to in it, -5 is just a point. We can include it, so we'll use a bracket because of the equal to in the original problem. And then I need to put these 2 pieces, region 1 and 3, together using a U for a union symbol. But that's it. And I say that's it, but that's a lot. And so this is kind of your worst case scenario where you had 2 fractions on opposite sides. You need to get them on the same side so you've got 0 on the other side. But then you still need to join them together as one big fraction by getting a common denominator. So these are very detailed. You can't just spit out an answer. So if you just give me an answer on a test, it's going to be right or wrong. I can't assign partial credit. You need to show your work, and you need to know when you need to draw these type of graphs. And you need to draw these type of graphs when you're dealing with an inequality, meaning you've got a greater than, less than, greater than or equal to, and you don't just have an x. You've got an x squared or a fraction or something. It means you need to really draw a graph in order to figure out what's above the x-axis and what's below by testing points and finding critical values. But it's a lot of information. And we do cover this in our college algebra courses. Actually, these are the same exact problems I go over in my college algebra courses. And we will use this off and on in this course. And if you do take trig, you'll use this. Or if you do take calculus at some point, you will need to know and remember most of this stuff.